we can see the decoded values coming from our ID token. What we are mainly interested in is the payload, where we can see the expiration time of this token, which is relatively low. It's currently set to only 5 minutes from the moment that I requested the token, and this is something that we can configure in our Keycloak realm. Another thing that you can see is who is the issuer of this token, and this will be important in the next lesson where we implement authentication with ASP.NET Core. You can see that the audience property is set to the client that was used to authenticate with Keycloak. The subclaim or subject is going to contain the user's identifier on the Keycloak realm, and we can also see a few other values, such as if the email was verified, what is the name of the user, what is the email of the user, and so on. Let's go back into Postman and let's grab the access token this time. The ID token should not be used for authentication purposes. It should only be used to verify that the user is a valid user in our system. For authentication purposes, with a backend application, for example, we should use the access token. And if I remove the ID token and then paste in the access token, you can see that some of the values in the payload have changed. The issuer is still the same, but the audience is now account instead of the Evently public client, which was the case with the ID token. It also contains some more claims, such as what is the allowed realm access and resource access for this access token. This is used to enforce authorization policies on the Keycloak user management interface. We also have the user's identifier in the subclaim and then a few more values. Now let's go back into Postman and talk a little bit about the refresh token. Under the access token, you can see the refresh token, which has a considerably longer lifetime. The access token expires in 300 seconds, which is 5 minutes, whereas the refresh token expires in 1800 seconds, which I believe is 30 minutes. So what can we do with the refresh token and why does it have a longer lifetime? The general idea to improve application security is to have your access tokens be short-lived, and then you would have a longer-lived refresh token which you can use to exchange for a new access token and ID token pair. So if we take the refresh token value and then open up the refresh token request, which is also hitting the same token endpoint as the access token request. However, what's different this time is we are using a different grant type. So we are requesting a refresh token as the grant type. The client ID is the same, and then the most important argument is the actual refresh token value. Here, I'm going to paste the refresh token that I got back in the previous response. And if we send this request to our Keycloak instance, we're going to get back a new pair of an access token, a refresh token, and an ID token with an updated expiration time. So this is the general idea. You would get a short-lived access token, use it until it expires, and then use the refresh token to obtain a new access token instance. Now, in order to make our life a little bit easier while developing this application, let's increase the access token lifetime. If you open up the realm settings page on the Keycloak admin user interface for the Evently realm, you can head over to the Tokens tab, and then under the access token section, you can configure the access token lifespan. And let's set this to 1 hour or 60 minutes so that we don't have to update the access token value so frequently. I'm going to save these settings and then head back into Postman. If I send another request to obtain an access token, you will see that the expiration time is now updated and it's 360 seconds, which is 1 hour. And I'm noting that I am doing this just for development purposes so that I don't have to refresh the access token as often. I'm going to close this down, and then let me quickly show you the client credentials flow using our confidential client and the respective client secret value that I obtained from the credentials section on the confidential client details page. What's different this time is that I'm using the client credentials as the grant type, and then I need to specify the client ID and the client secret. The request will also be sent to the token endpoint, so nothing changes there. If I send this request, you can see that we get back an access token, an ID token, and no refresh token this time. And we can use this access token to authenticate with Keycloak on behalf of our backend application. So the client credentials flow is more appropriate for server-to-server communication. And then let me also briefly mention the health endpoint. It's exposed on this URI, and you can use it to check what is the status of the Keycloak service. In this case, you can see that the health check returned 200 OK, which means that Keycloak is in a healthy state. Now let's go back to the Keycloak dashboard, and I want to show you one more thing. I'm going to navigate to the realm settings page for our Evently realm, and in the available actions over here from the dropdown, I can select partial export. And this allows me to export my Keycloak setup so that I can subsequently import that setup and reuse the same configuration in a different deployment. Another use case for this is setting up the Keycloak instance inside of your functional tests in ASP.NET Core. So if I click partial export, then I'm going to include the groups and roles as well as the clients, and then you can click export, and this is going to generate a JSON file. If I open up the Realm export file in VS Code, you can see that it's a pretty big JSON document, so more than 2000 lines, and it contains the entire setup for your Keycloak realm. Now, if I look for Evently confidential client, we're going to find a few matches for this query, and I want you to find the one where you can also see the secret value in the JSON document. And this is actually the client secret, which is not exported by default when exporting the Realm setup. Now this is expected because we don't want to share secret values such as the client secret, but if you want to reuse the same realm in multiple places, especially inside of your functional tests, then you will have to assign the client secret as part of the Realm export. So for testing and development purposes, you can add the client secret value, and then it will be included when importing the Keycloak realm when the Docker container is starting. Under this video, I'm going to include a Realm export file that I will be using in the remainder of this course. So if you want to keep it consistent with my implementation, I suggest that you also use that Realm export file. And before we wrap up this chapter, I want to leave you with a few troubleshooting tips in case you run into problems with setting up Keycloak or importing the Keycloak realm from the export file that I will be including. Most of the time, this is because the image that you are using for Keycloak for some reason becomes corrupt, or there is a problem with access privileges under the volume containing the Keycloak container. So the best course of action would be to completely clear your Docker Compose setup by running the clean solution command from Visual Studio. Then another thing that you can do is to remove the cached Keycloak image from Docker and force it to pull the latest version of the image. Most of the times this should be sufficient to fix the problem. Of course, you don't have to do this for the Docker desktop. You can also do it from the command line if you prefer that approach. And another thing that sometimes helps is restarting Visual Studio. So these are just a few troubleshooting tips that you can try to make sure that Keycloak is up and running correctly. However, I'm pretty confident that you won't be running into any problems. And we can wrap up the chapter about setting up the Keycloak identity provider. I showed you how to add the Keycloak container into our Docker Compose setup, how to configure a Keycloak realm and a public and confidential client, and how we can use these clients to authenticate with our Keycloak instance. In the next lesson, I'm going to show you how to implement token-based authentication with ASP.NET Core.